collector as when you use bipolar junction transistor with common collector configuration, we refer to it as emitter follower, because current gain is 1, means collector current is approximately equal to emitter current, because what is AC current gain, as we have defined it, ratio of collector current to the emitter current. So, if alpha is 1, that is gain is 1, IC over IE is equal to 1, this means IC is approximately equal to IE. If there is any change in emitter current, the same change will be depicted in the collector current, that is why it is called emitter follower. This is a comparison of transistor configurations. In the case of common base, input resistance is low. In case of common emitter, input resistance is high. In case of common collector, this input resistance is very high. Output resistance very high in common base, low in common collector, and it is moderately high in common emitter. Voltage gain is high in the case of common emitter, low in common base and very low in common collector. Where they are applied, where we use them, common base is used for high frequency applications, common emitter is used for audio frequency application, and when we have to do impedance matching, we use common collector configuration. So, common emitter circuit is the most efficient one, reasons that it gives you a high current gain and high voltage and power gain. Then let us study how transistor is used as an amplifier. You can again use 3 types of amplifier circuits when we deal with transistor. You can have common based amplifier, common emitter amplifier and common collector amplifier. The emitter is forward biased by using emitter based battery, collector is reverse biased by collector biased battery. So, input resistance is small and output resistance is large. So, if emitter current is referred by IE, base current by IB and collector current by IC, then using Kirchhoff's law you can show that IE is equal to IB plus IC. This is the circuit using NPN transistor for common base. Base is common here, means base is earth. And remember, emitter base junction is always forward bias. Emitter is N type, so it has been connected to the negative of the battery. Base is P type, so it has been connected to the positive of the battery. So, positive battery terminal to the P type, negative battery terminal to the N type, this means this is forward biasing. In the case of collector base junction, it is reverse bias. Reverse bias means to the N type we attach positive of the battery and to the P type we attach negative of the battery, ulta, reverse. Now, what happens is that when we apply a voltage here, when the positive half cycle comes on to the emitter, as emitter is connected to the negative, this positive terminal decreases the forward biasing. So, emitter current is decreased, and emitter current we know is sum of base current and collector current. If emitter current decreases, base current decreases. If base current decreases, collector current also decreases. Now, voltage that comes on the collector is basically equal to the battery voltage that has been applied minus the product of current and load resistor. Now, as current flows in the collector circuit, a potential difference equal to ICRL occurs across the load resistor, which has been referred by RL. So, this decreased emitter current decreases collector current. If collector current decreases, if this IC decreases, this means potential difference across the load resistor has decreased. If this has decreased, this means this has increased, VCV has increased. Collector is connected to the positive pole of the battery. This means if VCV has increased, this means it has become more positive, that is positive output is obtained, means positive half cycle has increased. Now, when second half cycle of input is negative, when this comes, emitter has been already connected to the negative terminal and you have put more negative voltage on it or current. So, it will increase the forward biasing. Increasing of forward biasing means emitter current has increased. If emitter current has increased, collector current has also increased. If collector current has increased, voltage drop across the load resistor has increased, and if voltage drop here has increased, voltage across the collector is coming lesser, but collector is connected to the positive terminal. If voltage has become less here, this means something negative has come here. This means it has become less positive. Less positive means it has become more negative. So, you get amplified output. AC current gain is the ratio of change in collector current to change in emitter current at constant collector voltage. AC voltage gain, a ratio of change in output voltage to change in input voltage. So, it is delta IC into R, this is output voltage, delta IE into R, this is input voltage, and if it is power gain, it is the ratio of change in output power to change in input power, and here you can show it as AC current gain square into resistance gain. This is PNP transistor. So, you use NPN or PNP here again, but here the terminals have changed. If you see, it is a PNP type, this means the emitter is P type, base is N type. So, positive of the battery is connected to P type, negative to the N type. Now, here when positive half cycle comes, emitter current increases, becomes more positive. This means the emitter current has increased, and we have seen that IE is equal to IB plus IC. You can use the Kirchhoff law here. Emitter current is entering here, base current and collector currents are coming out. So, emitter current is equal to base current plus collector current. If emitter current increases, collector current increases. If collector current increases, voltage drop across this load resistor increases. This means VCV decreases. You can use this equation, VCV is equal to the total battery that has been attached, voltage of the battery VCC minus ICRL. So, if ICRL has increased, VCV has decreased. VCV has decreased means it has become less negative. Less negative means more positive. Now, when negative half cycle comes, it decreases the forward biasing, emitter current decreases, collector current too decreases. So, the voltage drop across the load resistor decreases. This means this thing which is getting minus from VCC, it is lesser. जो minus हो रहा है वो cut minus हो रहा है. This means VCV will increase. VCV increases means negative voltage on the collector has increased, means it has become more negative. So, for the second half cycle it has become more negative. Then common emitter amplifier. Here emitter terminal is made common, means earth. Initially we were studying about common base amplifier. There when input is positive, output is also positive. Here you will see there is a phase reversal, you have to remember this. When you use it as a common emitter amplifier, this is an NPN transistor, base is P type, emitter is N type. So, again forward biasing has to be put up, base is P type. So, positive terminal of the battery has been attached to the base. As emitter is N type, negative terminal is attached to the N type, that is emitter. Collector emitter junction has to be reverse bias. It is N type. So, here it should have been positive terminal. So, there is a positive terminal here. So, the emitter is common to both input and output circuits. Emitter is forward bias, collector is reverse bias. a low input signal is applied in base emitter circuit and you get an amplified output across the collector emitter circuit. Again, voltage across collector is equal to collector and emitter is equal to voltage across the collector that has been given by the battery minus the voltage drop across the load resistor. Supposingly the first half cycle is positive, base we have already connected to positive. So, it will make the base more positive, means forward biasing increases. This means the emitter and collector current, they both will also increase. So, if the collector current increases, potential drop across load resistor also increases. So, this means VCE will decrease. As collector is connected to positive pole, the decrease in collector voltage means it has become less positive. Less positive means more negative. So, this means when there is a positive positive half cycle in the input, you get a negative half cycle across the output. When there is a positive half cycle in the input, there is a negative in the output. When negative half cycle comes at the input, but you have attached base to the positive of the battery, you are getting a negative voltage which is to be amplified. This means you are decreasing the forward biasing of the base emitter junction. Base becomes less positive, means its forward biasing is decreased. This means base current decreases. If base current decreases, emitter current and collector current has also decreased. If collector current decreases, potential drop across this load resistor decreases. This means potential which is coming onto the collector has increased. It is already connected to the positive. Here we just put a positive terminal. So, if potential across the collector is becoming more positive, this means it has increased. Positive half cycle has, there is an increase in the positive half cycle. Now, when if you see here, when input positive is there, at the output you get a negative half cycle. So, there is a phase reversal of 180 degrees in common emitter amplifier. AC current gain is represented by beta here. Now, at the input you had base current, at the output you had collector current. So, the ratio of change in collector current to change in base current is called AC current gain. Transconductance, ratio of change in collector current to change in base voltage at constant collector voltage is called transconductance. So, delta IC upon delta VBE, multiply numerator and denominator by delta IB, you get beta AC into 1 by R input. So, relation between GM, beta and R input is that beta is equal to GM into R input. AC voltage gain, ratio of change in output voltage to change in input voltage. AC power gain, ratio of change in output power to change in input power. So, voltage gain means output voltage. So, it is output current into output resistance. Input voltage means input current into input resistance. Delta IC over delta IB we have referred as AC current gain, beta AC, multiplied by resistance gain. You can also show AV as equal to GM into R output. This is a practical common emitter amplifier circuit. This is the input signal source, and here you have an PNP NPN transistor that has been used. This emitter has been urged. There is a capacitor here across the emitter. These are the biasing resistances which are used so that proper biasing can be given. We have studied about transistor as an amplifier. Then transistor can also be used as a switch. This circuit shows you transistor being used as a switch. So, you might have understood about the transistor, how the transistors work. Then application of transistor as a common emitter and common base amplifier, then you can also use transistor as a switch. In the fully on state, the voltage across the transistor is almost 0 and transistor is said to be in saturation. So, this is how the transistor is used as a switch. Thank you.